So we're jumping into topic 3, but with topic 3, we want to look at some vocab here, and a lot of this is going to be familiar to you. Some of you have already written this down and we've discussed it. Please make sure you have everything written down that I write down. So let's go ahead and look at these 5 different vocabulary words. Number 1 is ordered pairs. I think we all know what an ordered pair is, and I just want to remind you that an ordered pair is X, comma, Y. So the first number always means the X value. The second number always means the Y value. Let's go ahead and look at our table. We've seen tables before. We've seen them horizontal and vertical. They're labeled XY. We can actually take those points out of a table and write them as ordered pairs. So example would be that we have the 5 goes with the 12. The 5 is the X and the 12 is the Y. So again, we can take ordered pairs and put them into a table, or we could write them from a table into ordered pairs. Let's look at equations. This specific equation we know is linear because of the form it is in. So we know because it is linear, it's going to create a line if we were to graph it. Okay, this is in the form of y equals mx plus b, where the m and the b means something specific. The m is the slope. In this example, my slope is 3. And the b is always your y-intercept. And in this example, your y-intercept is negative 12. So this is linear. We know this will make a straight line because it is in the form of y equals mx plus b. Again, ordered pairs, table, equation, and this graph, these are nothing new. We've seen all of these before. On the graph, just remember that your x-axis is going to be your horizontal axis, and your y-axis is going to be your vertical, which is straight up and down. And so the new one that we see here is called an arrow diagram. Some people also call it a mapping. So I want to write that above it as well. It can be called a mapping. I'll talk about how to create these later on. But what I really want you to know is that this first circle here, or oval, this represents our x values, and my other one represents my y values. Okay, so that's some vocab that I wanted to touch base on. Again, all probably old except for that mapping or arrow diagram. Let's jump into notes topic 3.1. I went too far. This is a super important topic, and it says, when is a relation a function? Okay, when is a relation a function? And so there is a very specific question we're going to ask ourselves when we are trying to determine whether a relation is a function. Okay, if I need to delete that, sorry. When we are trying to determine whether a relation is a function, the question that we want to ask ourselves is, is there only, well, let me repeat that. I don't like that one. Are all the x's different? Are all the x values different? That is the question that we're going to ask ourselves every single time to determine if it is a function. Let's look at what the definition of a function is. A relation is a function when each input, your input is your x value, is assigned to exactly one output, which is your y value. Okay, but if we ask ourselves that question every single time, are all the x values different, you will be able to determine if it is a function or not. So let's go ahead and look at this first example here. The input, or the weight of these boxes, is my x. The output is my y. So let's ask ourselves the question, are all your x values different? It's either yes or no. Yes, they are. So yes, this is a function. If all your x values are different, then yes, you will have a function. Now they took these ordered pairs in step 1 and they put them into an arrow diagram. I want to remind you the first one is the x and the second one is the y value. Let's go ahead and jump down to the try it and try to make this arrow diagram together. There's two important things when you make an arrow diagram. Okay? The first important thing is that we are not going to repeat a number. So don't repeat a value. The second most important thing is you want to put them in order. Place values in order. So if I go ahead and I look at all these ordered pairs, and I'm just going to go ahead and underline my x values. I have a 4, a 5, an 8, a 2, and a 9. So we're going to put those values in order, and we're not going to repeat a value. So the first one they have is a 2. The second one they have should be, we need to write in a 4, and then the 5, and then an 8, and then a 9. So we took all our x values and placed them in order. Now let's look at those y values. And the y values, if I were to underline those in yellow, 24, 35, 24, I said the same number twice, 20, and 27. So we are not going to repeat one, which is why you only see, I underlined 5 numbers, but you only see that they wrote 4 numbers in here because they didn't want to repeat it. And the last thing you do once you put your numbers in order is you connect them. So I go in order here. 4 goes with 24. I'm going to go to the 4 to the 24, draw an arrow. 5 goes with 35. I go to the 5, I draw a line to the 35. 8 goes with 24. 2 goes with 20. And 9 goes with 27. And that is how you would make an arrow diagram. The other thing I want to make sure that we are aware of is we could ask ourselves by looking at the red, what I underline here in red, are all my x values different? I have a 4, 5, 8, 2, and 9. Are they all different? Yes, so this is a function since they are all different. Let's look at the next one. Is to determine when is a relation a function, and we're going to ask ourselves that question, are all the x values different? Here we're looking at a table, and they've labeled the age as the x and the height is the y, and we're trying to determine if it is a function. So again, let's not make this challenging. Let's look at and ask ourselves the question. Look at the x's. Are all your x values different? No. So because they are not different, I see 2 number 9s and I see 2 number 8s. No, not a function. Again, if you ask yourself that question each time, you'll be able to determine if we have a function or not. Let's go ahead and we can see in the try it here. Remember, age is x, so we want to label, they kind of put the x below the y's here. I don't like the way they set this table up. Age is x. Look at your ages. Are all your x values different? It's a yes or no question. No, they are not. So no, not a function. Always looking at the x values. Let's ladder this key concept box here. And of course, I always like the way that it spells it out here. It shows you a mapping. It shows you an table. And so again, the last thing I'd like for us to write down at the top of this key concept box is the question we're going to ask ourselves. Are all the x values different? Are all the x values different? That's what we're looking at. And it's a simple yes or a simple no. If we look at this first one and we look here at my x's, this is yes, a function, because they are all different. And if we look here at my table, this is no, not a function, because they are not all different. And that's